So let's do an example of interference of a wave, okay? So I'm going to write this question here. Let me use the two speakers Alright, so go ahead and finish copying this question. So two speakers are 3 meters apart and play identical tones of frequency 170 Hz. Sam stands directly in front of one speaker at a distance of 4 meters. Is this a loud or quiet spot? Use the speed of sound in air v equal to 340 meters per second. So try to work on this and see if you can come up with the answer, okay? Okay guys, so I'm gonna erase this, okay? I have this information in my notebook, so for you guys, you look at it on your notebook, okay? So just like in every problem in physics, we are going to write the detailed information, we are going to write the given information, draw a diagram, and then solve, okay? Here we are given two speakers are 3 meters apart. So two speakers are 3 meters apart. So let's say maybe this point as 1. Let us call this, I don't know, this is, let's call this, okay, this is, let's say 1, this is 2, and then you are sitting somewhere. Oh, this distance is given to us. This distance is 3 meters apart. And then they play identical tone of frequency of 170 Hertz, okay? So this some distance, I'm going to just call some R, is 3 meters apart. And then it's playing some frequency F equal to 170 Hertz. Sam stands, well, it was not you, I thought it was you, I forgot. Okay, so Sam stands here, Sam is here, okay, Sam stands here, directly in front of one of the speaker at a distance of 4 meters. Okay, so this distance to here, this distance is 4 meters. Okay, so let's call this as a D1, the distance from the speaker 1, right? And now, is this a loud spot or a quiet spot? Assume that the speed of sound in air is 340 meters per second. Is this spot a loud spot or quiet spot? What does that mean? Whether this person hears the, whether these waves will produce constructive or destructive interference. What does that mean? Constructive or destructive interference means we have to really look at the relationship delta D equal to m lambda or m plus half times lambda, right? This is the condition, okay? So this is the question we are asked when we are asked about, whether this point is quiet or loud, okay? This is the thing we are going to investigate here. And then we are also told that to assume the speed of the sound is 340 meters, so D equal to 340 meters per second, okay? Now, first and foremost thing is, we know what the path difference delta is given by, let's call this is D1, let's call the distance from the speaker 2 to the person as D2, okay? So D2, and then the path difference is given by what? Delta D equal to D2 minus D1, right? Okay, but delta, so how do we find D2? We don't know this D2, right? This D1 is given to us, this is 4 meters, right? Okay, so I forgot to write that D1, so D1 is 4 meters, okay guys? So if we look at this, this is like really like a right angle triangle like this, right? We are given this 4 meters, this side is given 3 meters, we just need to find this hypotenuse, that's, by using Pythagorean theorem. So using Pythagorean theorem, we can find this, right? This hypotenuse, in our case, hypotenuse is what? D2, right? So Pythagorean theorem says what? The hypotenuse H is given by square root of perpendicular b square plus b square, where b is base. You may have seen other version of this, okay? So don't get hung up on this equation. So in place of hypotenuse, we have our D2. D2 is what? The square root of our perpendicular. So that's a 3 square plus the base. This is 4 square, okay? So that gives us what? The square, that's the 3, that's a 9, right? Is 3 square 9, so that's 9 plus 16, which is 25. Square root of 25 is 5. Okay. So that we found this distance d2 is 5 meters. So this distance d2 is 5 meters. Okay, that's what we found. So that's not enough, but we have to now go back to this part here. This is what we need to evaluate, right? Someone erase this part here. I'll need this information about frequency in a bit. So, but delta D equal to what? D2 minus D1, which is what? D2 is now 5. This 5 minus 4 is what? 1 meter. Delta D. Okay, so this is one of the condition now, part of the condition. Now we have to look at the other part, right? So now we need to see what happens, what is the wavelength, okay? So next part is we do need to know what is the wavelength. So this studied, but also V equal to F times lambda, that gives us lambda equal to V over F. B is, what was the B? 340 divided by frequency is 170. This cancels, so please guys put this in a calculator and then see 34, right? 2, 17 times 2 is 34. Okay, so lambda is 2 meter, right? Okay, so these two are the things that will help us determine whether this person is sitting at the quiet or loud spot. Okay, so now if we look at delta D is what? This is a 1 meter, right? Delta D is half of lambda, right? Delta D, which is 1 meter, is half of 2 meter, right? So since we are going to say since delta D is half of lambda, Sam is at quiet spot. Make sense? Because remember this, right? This condition is delta D equal to m plus half times lambda. This is a condition for destructive interference. So here the destructive interference is taking place, so this person doesn't hear anything basically. Okay? So this person is at quiet spot. Alright? Okay guys, so that's about it for the example for interference and diffraction.